Hello and welcome to your first module on main group chemistry. Somehow, over the next 3 or 4 years, depending on your degree, we need to get across to you a whole ton of so-called descriptive chemistry, facts associated with all of the elements on the periodic table, their types of compounds, and so on. For me, the most important aspect to this is that you first of all get a feel for how it's set up, but much more significantly, that you see all the chemistry that you're learning conceptually at work. So, for example, when we're talking about how we get the elements, the sources of the elements, I want the main idea you come out of that is that if the elements aren't there naturally, then what we have to do is somehow get them out of their compounds, and the way we generally do that is with oxidation or reduction, because if they're in a compound, they don't have an oxidation state of 0. It's either a positive oxidation state, so we have to reduce it, or a negative oxidation state, so we have to oxidize it to get back to that elemental 0 oxidation state. Differences between metals, non-metals, and metalloids, differences in types of structures, and so forth. All of these things that you've touched on at different points during the course, and now what we want to do is show their applications associated with main group chemistry. And of course, yes, you're going to have to learn some facts and so on, but hopefully it's not quite as boring as just sitting down and here's a whole bunch of reactions that you have to do. Anyway, what do I mean by the main group? Well, here's the important part of the periodic table for this. Breaks my heart because, of course, I have pulled out the most significant part of the table, that between calcium and gallium, strontium and indium, barium and thallium, in other words, the transition metals. But we talk about those somewhat separately. I might rethink that for future years, because it would be interesting to tie in the transition metals there. But anyway, you're not doing that. You are interested in this main group made up of the so-called S block, which is, of course, these two groups here, the alkali metals, the alkaline earth metals, and then this weird, strange little atom here, hydrogen, is also part of the S block. And then, of course, the P block, which is the rest of them, including the most important group on the periodic table in terms of defining chemistry, the noble gases. So anyway, I mentioned some of these group names, and you do need to know those. So in the S block, the first group, the alkali metals, of course, hydrogen is not a metal, so it's not an alkali metal, even though it's in group 1. And then the other one being the alkaline earth metals. Over here on the P block side, by now you all know the noble gases. If you don't, then, well, I won't say anything because it'd just be too nasty, but let's just assume that you all know those. And of course, you also know that the group before those are the so-called halogens. Now, only those probably who watched my old movie on the periodic table, unless you had a historically inclined or a geologically inclined teacher in high school, will know that this group is the chalcogens. Some people do not put oxygen in chalcogens. In fact, the original use of the word does not have oxygen in there, but as a group name, it's convenient to refer to these as the chalcogens. And in the same way, this group here, group 5A on the old good numbering scheme, are known as the pnictogens. It's a silent P. It also has a T in there. You'll sometimes see it written without the T. That is incorrect. It is pnictogens. Now, it's kind of funny historically, the groups 3A and 4A are on the newfangled periodic tables, group 13 and 14, don't have names that are readily available, but at different times people have tried to give them names. So, for example, the first group here, 3A or 13, some people used to call them the trials. I like the word icosagens. If you want to be really boring, you can call them the boron group. And in a similar sense, group 4A, on group 14, some people call them the tetrals. I like crystallogens, or you can be a boring old whatever and call them the carbon group. I am going to be referring to these groups as we go through by these names. It would behoove you to be familiar with them so that when I say, and here's the icosagens, you know exactly what I'm talking about. And I will say the icosagens, I will not be boring and say the boron group. I will not be boron and say the boron group. Gosh, you can tell us early in the morning, can't you? When we look at our main group elements as we go through this, we're going to be classifying them in different ways. And one of the most familiar ways, and this is review for you, I hope, is metals, non-metals, and in between. So the metals, right, before I pull it up, in this pretty little pinkish color. Which ones are the metals? Well, obviously the alkali metals, the alkaline earth metals, and then 4 members of the icosagens, 2 members of the crystallogens, and then all by itself this strange little element down here, bismuth. Bismuth is kind of a fun one. We'll talk about how that's fun as we go through the next couple of years. So anyway, here are the metals, and of course we left out the transition metals, which are what give the appearance, and in fact the truism, that metals make up the bulk of the periodic table. If it's not a metal, like that one displayed there for potassium, it's probably a non-metal. And again, before I click this next slide, where are the non-metals? There we are, the noble gases, all of the stable halogens, 3 of the chalcogens, 2 of the pnictogens, and then carbon all on its own as the representative of the crystallogens. And of course, this lone, strange, weird little element here, hydrogen, is also a non-metal. Okay, now the metals, of course, are shiny. They are silvery colored, very few exceptions. They're solids. Always fun, sort of, which are the ones that are not solids. Well, mercury is, of course, the classic one, but cesium and gallium, if you warm it up past typical room temperature in Swansea, they are definitely solids. Room temperature in Houston, it could well have been liquids there. But anyway, generally metals, solids, always shiny, ductile, malleable, conduct heat, conduct electricity, and so on. Non-metals, and here's some pictures of them. There's sulfur. Definitely not ductile, not malleable, generally not shiny. Chlorine, of course, is a gas. And then iodine is a solid, and it's shiny, but it doesn't conduct, and so forth. Okay, now if it's not a metal, and it's not a non-metal, it must be a metalloid or semi-metal. Okay, so you have to be familiar with boron, silicon, germanium, arsenic, antimony, and tellurium as the metalloids. Okay, they're metalloids or semi-metals. They have some properties of metals. They have some properties that are closer to the non-metals. There, for example, is boron that looks nice and shiny, and so on. Not the greatest conductor of heat, not the greatest conductor of electricity, and so on. Now, these two down here, I tend to think of these as metalloids, but polonium and astatine only available as radioactive nuclei. There's been some chemistry done with these, and there's a really nice little paper from 2013 Journal of Chemical Education in which this person, I can't remember their first name, but they're from some strange university in Australia. They went through and analyzed all of the descriptions of polonium and astatine, some as metals, some as non-metals, some as metalloids, and sort of put it in a nice little summary. So I'm not going to talk further about those in the main group course, but it would be worth you going and pulling out that article. In fact, I think I might link it to the Blackboard shell and just reading through it to have fun with the debate about what are those. Anyway, very, very important that you're happy with the metal, metalloid, non-metal distinctions around the periodic table. Now, of course, you're not coming at this module from a vacuum. You do know quite a lot about the periodic table, and in particular the periodic properties, and we will be referring to these from time to time as we go through, and I do expect you to be familiar with these. As we go, for example, from left to right on the periodic table. Okay, so along a period, right, would be one way to say it, along a row. Size decreases, so therefore in this second period, lithium is the biggest, neon is the smallest. The ionization energy increases, and it's got a little star there because you should remember the little zigzag. So for example, lithium is less than beryllium, but beryllium is bigger than boron. Boron is less than carbon. Carbon's less than nitrogen. Nitrogen is, however, bigger than oxygen, and that's of course the half-filled p stability with the exchange energy, the lack of repulsion, and so on. Oxygen less than fluorine, fluorine less than neon. So you do need to remember that. The electronegativity increases as you go from left to right, and of course the noble gases at this stage we don't say have an electronegativity, so fluorine is the most electronegative atom on the periodic table. Non-metal character increases, and you can see there's the metals, there's the semi-metal in boron, and then we get into the non-metals there. And these are better oxidizing agents. In other words, they want to be reduced as you go from left to right because they want to make anions. Going down, of course, same trends. Size increases because you're going from one shell to the next shell to the next shell. Ionization energy decreases the further away the electron is from the nucleus, and the more shielding that it accomplishes, the easier it is, or the more shielding it experiences, the easier it is to pull the electron away. Electronegativity decreases. The metal character increases, so therefore the most metallic stable element is expected to be cesium, and as you go in this way they become better reducing agents. In other words, they want to be oxidized, they want to lose electrons. Okay, you've been talking about these starting a little bit in GCSE and A level and in previous modules here, so I expect you to be fully au fait and knowledgeable of those trends.